So I'm sure in this course of high energy physics, you have gathered a lot of information. And if I just go through the topics that we have discussed here, I'd like to just share my screen here and then tell you. Basically, if you look into the course, we started with the basic introduction on high energy physics, and we did talk about elementary particles. Also talked about neutrino oscillations and string theory. So high energy physics more or less deals a lot with elementary particles, how things work on the atomic, molecular, nuclear level. It's very important. But how do you produce and detect those elementary particle forms an important part as well. And then we talked about the unification scheme, and we know that unifying all the forces, four kind of forces, is kind of challenge, and people are actually working on that, and gravitational field being the weakest of them all, although very important, it becomes a bit difficult to incorporate this into this unification scheme. Also talked a bit about the quantum chromodynamics. Now, in this part, what I'd like to tell you is regarding the research that is basically going on currently in high energy physics. Although, if you want to actually know about the research part, you can definitely go to something which we call as the Google Scholar. You can go there and then type any kind of keywords. Maybe you can type elementary particles, okay, and or you can actually type uh, elementary particles can be an important keyword. You can just simply type nuclear, high energy physics, and so on, and then you can get all the details of the latest research that are being carried out. What I can do is I can go to any time, or I can just look for the latest research, maybe since 2024 or since 2021. So you can go since 2021, and you can see these are the work that are being done. Now these are some book chapters and all. If you go into the research field, you can see that antiproton and elementary particle over a solar cycle results from the alpha magnetic spectrometer. So more or less the advanced countries like the US, Germany, Switzerland, they are basically working on this experimental part of high energy physics. And as we already know about the Large Hadron Collider, and then there we have the different systems, for example the Atlas. These are actually used to detect the elementary particles, so which are there and which are actually being difficult to detect in a normal system. It's a huge setup, basically the largest human-made experimental setup rather. So if you talk about high energy physics, you can go to this website of US Department of Energy, and you can see some latest works that are being carried out in the LHC. Okay, so if we look here, we can see you can see a lot of videos there. You can see how does the setup look like, and they will explain it. You can find a lot of documentary on different channels and YouTube as well. But if you look into the high energy physics programs that are going on right now, it can be talking about the energy frontier, the intensity frontier, the cosmic frontier. These are the setups that are there. These are all subparts of even LHC, and there are also some theoretical works that are being carried out. Okay, and then there are advanced technology, research and development accelerators, and so on. Okay, you can see and explore this page. It's energy.gov. Okay, and you can go to this site and check. I like to talk a bit about on the theoretical concepts that are being done right now. So if you go to this topic on theoretical, computational, and interdisciplinary physics, especially in the field of high energy physics, this plays a very important role. Many a times, if you do a setup, perform the experiment, and then you are not getting the result that you are expecting, there is a lot of wastage of resources. So it is always a good idea that we actually combine the theoretical or the computational work with the experimental work. Sometimes the theory predicts a particle based on which an experiment can be carried out, and it can actually give you better information, and also it will save a lot of resources. Theory and experiment goes hand in hand. Experiments mostly are true, theory sometimes might be wrong. It does happen that the experiment has been performed and the theory which was there given previously was disproved, and then again a new theory has been given so that it supports the experimental result. So these things are very important. You can see this image from Atlas. Okay, this is basically, if you look into this image, let me enlarge this photo. These larger lines are actually representing the muons. Okay, so you can see these larger lines will actually represent the two muons, okay, long blue lines, and the two electrons which are there after the reaction are represented by the short blue lines. You can check it again, and you can see that these are the short blue lines which are actually representing the electrons. And of course there is an enormous amount of energy that is being generated. So you can just go through these pages and you can explore that what is being currently done in high energy physics. So with this edition I would like to stop for this part of the lecture. I'll keep on adding more to this lecture series. Okay, hope you are enjoying the videos. Thank you.